Hello students, this is Mrs. Madhavi S.Salodkar going to take lecture for TY BCom students. Name of the subject is Business Statistics second paper. This is 71st lecture, second term, unit 6, lecture 3. Name of the topic is Testing of Hypothesis, first part. Today we are going to see testing population proportion equal to specified value and problems and examples based on this particular test. This is the third large sample test. First two tests already we have covered in the previous lectures. So see the contents. See the next example. The manufacturer of a patent drug claimed that a specific drug was effective in 90% cases in relieving an allergy for a period of 8 hours. In a random sample of 200 people who had the allergy, the medicine provided the relief to 160 people. Is manufacturer's claim legitimate? So in this case the claim is in percentage. So we can say that the test is based on proportion. So H0 in notation is equal to P is equal to P naught against H1 P not equal to P naught. So H0 in words can be written as a specific drug may be effective in 90% cases in relieving an allergy for a period of 8 hours. So under H0, the test statistic is given by Z is equal to P minus P naught upon square root of P naught Q naught upon N, where small p is equal to X upon N, which is nothing but the sample proportion, which can be calculated as 160 upon 200, which is equal to 0.8. P0 is the claimed proportion, so which is nothing but 0.9. Q0 is 1 minus P0, so 1 minus 0.9, Q0 value is 0.1. And N, which is nothing but sample size, the value is 200. See the calculations. Z, test statistic Z is written as P minus P naught upon square root of P naught Q naught upon N, which is equal to 0.8 minus 0.9 divided by 0.9 into 0.1 upon 200, which is equal to minus 0.1 divided by square root of 0.00045, which can be written as minus 0.1 upon 0.02121. So if you perform the division, the final answer is minus 4.7140. Now mod Z calculated is equal to mod minus 4.7140, which can be written as 4.7140 is greater than 1. It should be 1.96. Is greater than 1.96. We reject H0 at 5% level of significance. And mod Z calculated is equal to 1 mod minus 4.7140, which is equal to 4.7140, which is greater than 2.58. We reject H0 at 1% level of significance. So conclusion can be written as a specific drug may not be effective in 90% cases in relieving allergy for a period of 8 hours. Next example. 200 people were attacked by a disease and 180 survived. Can we say 85% people survive if they are attacked by this disease? Use 5% level of significance. Again, the claim is in percentage, so we can say that the test is for testing population proportion is equal to specified value. So H0 in notation is written as P is equal to P naught against H1 is P not equal to P naught. So H0 is equal to, the H0 in words is 85% people may survive if they are attacked by this disease. Now under H0, the test statistics can be given by Z is equal to P P minus P naught upon square root of P naught Q naught upon N, where P is equal to sample proportion, which can be calculated as X upon N, which is equal to 180 upon 200. So the answer is 0.9. P0 is the claimed proportion, which is nothing but 0.85, because they have made the claim for 85% people. So P0 is equal to 0.85. Naturally, Q0 is nothing but 1 minus P0, which is equal to 1 minus 0.85, which can be written as 0.15. And sample size N is equal to 200. So Z is equal to P minus P naught upon square root of P naught Q naught upon N, which is nothing but 0.9 minus 0.85 divided by square root of 0.85 into 0.15 divided by 200. So the answer is 0.05 divided by 0.025248. If we perform the division, the Z calculated value is given by 1.98029. So mod Z calculated is equal to mod 1.98029 is equal to 1.98029, which is greater than 1.96. Therefore, H0 is rejected at 5% level of significance. As they have mentioned the level of significance as 5%, we can conclude the statement by writing conclusion as 85% people may not survive if they are attacked by this disease. See the next example. A company producing spark plugs claimed that there would be 10% defective spark plugs. When a sample of 500 was taken, 62 were found defective. Test correctness of company's claim. If you see the problem statement, the claim is in terms of percentage. So we can write the null hypothesis of this test as P is equal to P naught against H1, P not equal to P naught. H0 in words can be written as there would be 10% defective spark plugs. Under H0, the test statistics is given by Z is equal to P minus P naught upon square root of P naught Q naught upon N, where P is equal to X upon N, which is nothing but the sample proportion, which can be calculated as 62 upon 500, which is equal to 0.124. P naught is for 10%, so P naught is equal to 0.10. Q naught can be calculated as 1 minus 0.10, that is nothing but 0.90. And sample size N is nothing but 500. So Z is equal to 0.124 minus 0.1 divided by square root of 0.1 into 0.9 divided by 500. So which is equal to 0.024 divided by 0.01341. So the answer is coming as 1.7888. Now mod Z calculated is equal to mod 1.7888, which can be written as 1.7888, and we can see that this value is less than 1.96. Therefore, we accept the claim at 5% level of significance. So conclusion can be written as there may be 10% defective spark plugs. Hence, company's claim may be correct. Next example. A soap manufacturing company claims that 36% of households use their brand of soap. In a survey, it is found that of 1,600 households interviewed, 512 used the soaps produced by the company. Is the company's claim justified? Use 5% level of significance. So H naught in notation can be written as P is equal to P naught against H1 P not equal to P naught. So H naught in words can be written as 36% households may use the soaps manufactured by a company. Then under H naught, the test statistics is given by Z is equal to P minus P naught upon square root of P naught Q naught upon N, where P is equal to X upon N, which is nothing but the sample proportion, which can be written as 512 divided by 1600. So the answer is 0.32. P0 is the claimed proportion. They are claiming for 36%. So P0 is equal to 0.36. Q0 is nothing but 1 minus P0. That can be calculated as 1 minus 0.36. So the answer is 0.64. See the calculations, and we know that N is equal to 1600. So Z is equal to 0.32 minus 0.34 divided by square root of 0.36 into 0.64 divided by 1600. So that is equal to minus 0.04 divided by 0.012. So the answer is minus 3.3333. Then mod Z calculated is equal to mod minus 3.33 can be written as 3.3333, which is greater than 1.96. Therefore, we reject H naught at 5% level of significance. Conclusion: 36% households may not use the soaps manufactured by a company. Next example. In a sample of 500 parts manufactured by a company, the number of defective parts were found to be 42. The company, however, claimed that 6% of their product is defective. Is the claim valid? Use 5% level of significance. So H naught in notation can be given by P is equal to P naught against H1 P not equal to P naught. So H naught in notation, H naught in words can be given as 6% of the product manufactured by a company may be defective. Under H naught, the test statistics is given by Z is equal to P minus P naught upon square root of P naught Q naught upon N, where P is equal to X upon N, which is nothing but sample proportion, which can be calculated as 42 upon 500. The answer is 0.084. P naught is the claimed proportion, which is 6%, so 0.06. Q naught is nothing but 1 minus P naught, which can be calculated as 1 minus 0.06. That value is 0.94. N is equal to sample size, that is equal to 500. Z is equal to P minus P naught upon square root of P naught Q naught upon N, which can be written as 0.084 minus 0.06 divided by square root of 0.6 into 0.06 into 0.94 divided by 500 in under root sign. So that is equal to 0.024 divided by 0.01062. The value is 2.2598. So mod Z calculated is equal to mod of 2.2598, which is equal to 2.2598, which is greater than 1.96. we reject H naught at 5% level of significance. Then we can write the conclusion as 6% parts manufactured by company may not be defective. See the next example. A random sample of 600 cars making a right turn at an intersection. 157 pulled into the wrong lane. Test the hypothesis that the actual proportion of drivers making this mistake is 30%. Use 5% level of significance. So the claim is in percentage. So we can say that the problem is based on third test, which is nothing but testing population proportion is equal to specified value or not. So H naught in notation can be written as P is equal to P naught against H1 P not equal to P naught. So H naught in words, the proportion of drivers pulled into the wrong lane is 0.3. Under H naught, the test statistics is given by Z is equal to P minus P naught upon square root of P naught Q naught upon N, where P is equal to X upon N, which can be written as sample proportion. P naught is the claimed proportion, Q naught is equal to 1 minus P naught, and N is sample size. So given that P is equal to X upon N, so we'll calculate the value as 157 upon 600. So the answer is 0.26166. They are claiming for 30%. So P naught value can be taken as 0.30. Q naught is nothing but 1 minus P naught. Therefore Q naught is equal to 0.7 and sample size N is equal to 600. So Z is equal to 0.26166 minus 0.30 divided by square root of 0.3 into 0.7 upon 600, which is equal to minus 0.03834 divided by 0.01870. So the answer is minus 2.04935. Now they are saying we have to test on 5% level of significance because the level of significance is mentioned here. So mod Z calculated is equal to minus 2.04935, which is equal to 2.04935, which is greater than 1.96. Therefore, we reject H naught at 5% level of significance. Conclusion: the proportion of drivers pulled into the wrong lane may not be 0.30. Next example: a manufacturer of a spot remover claims that his product removes at least 90% of the spots. What can we conclude about the claim at 5% level of significance if the spot remover removed 174 spots out of 200 chosen at random? So H naught is nothing but P minus P is equal to P naught against H1 is P not equal to P naught. So H naught in words, the product may remove 90% spots. Product may remove 90% spots. Under H naught, the test statistics is given by Z is equal to P minus P naught upon square root of P naught Q naught upon N, where P is equal to X upon N, which is nothing but sample proportion, which can be calculated as 174 upon 200. So value of P is 0.87. P0 is the claimed proportion. They are claiming for 90%. So P0 is equal to 0.90. Q0 is 1 minus P0, which is equal to 1 minus 0.90, which can be written as 0.10. And N is sample size. The value of N is 200. So the test statistics Z can be written as P minus P naught upon square root of P naught Q naught upon N, which is equal to 0.87 minus 0.90 divided by square root 0.9 into 0.1 upon 200, which is equal to minus 0.03 divided by 0.021213. So the answer is minus 1.4142. So mod z calculated is equal to mod minus 1.4142, which can be written as positive 1.4142, which is less than 1.96. Therefore, we accept H0 at 5% level of significance. Conclusion: the product may remove 90% of spots.